Hi, folks. In this one here, we're going to take a look at the connecting rod and piston. Again, this is one of the other major or core pieces of the engine. The major job of the piston and the connecting rod here are to harness the chemical energy from combustion and turn that into some kind of mechanical motion. In our case here, it happens to be that up-down or linear type of motion. Okay. The connecting rod is actually the piece in the middle here that connects the piston to the crankshaft, which we were looking at in the last part here. All right, here's the piston that you'll probably see coming out of your engine, and you can see the connecting rod here has some room to move. It can be fully disassembled by pushing the piston pin out. Okay, you will need to also unbolt the piston from the crankshaft by removing the cap piece here as well. Okay. So the connecting rod has a pin. We call that the piston pin or wrist pin. You can see that on the upper part of the picture here. Again, that has a very smooth or machined surface, very much like parts of the crankshaft. This is moving very fast, a couple thousand times a minute, and again, needs to get constant lubrication so that it doesn't overheat or get damaged. Okay. Oftentimes, the piston will have either one larger hole or a smaller hole on the side, so the piston pin or the wrist pin can only go in one direction. You'll probably also find some small little C-shaped or E-shaped clips. Those are called retaining clips, and you'll need to remove those before you take out the piston pin. Take care not to lose them or have them go flying as well. Okay. In addition, the wrist pin also allows for movement of the connecting rod. Okay, if we look on the inside of the piston here, we can see it's hollow on the inside. And as the piston is moving in the engine here, we kind of have this motion where the connecting rod is going to have to move back and forth as the crankshaft is turning, okay, in that other direction. But the head of the piston has to remain still in the cylinder. So the connecting rod has to be able to move around, okay? Down in the bottom end here, what they're calling the big end, we also often have another smooth surface. Sometimes you'll actually see a bearing here, and a bearing is like a ball bearing that might actually have the small little balls in between two tracks or races. But that would be for a much larger engine, and we probably wouldn't see that in these very small ones. But some really large engines or car engines would also have bearings there just to provide, again, super smooth movement so things don't overheat. All right, and then finally the rod cap, which is at the very bottom here, would allow really just for removal of the connecting rod from the crankshaft, so you'll need to unbolt that. These two bolts tend to be fairly specialized, so you want to make sure you keep track of those during disassembly. I would definitely bag them and tag them with some of the other little parts of the piston here, so that you don't lose them. And when we do put these back together, we'll have to make sure that we torque these to a very specific value. If the connecting rod is too loose or too tight, it can cause major problems. Too loose, obviously, it can come undone. But too tight can actually be a worse problem because it would be more prone to overheating, and that would cause either the engine to seize or actually will break the connecting rod. Is a very common major problem that would involve having to disassemble the engine to do the repair. Okay. And then finally here, many of the connecting rod caps have a little piece either that's bolted on that hangs on, or some of them built right into the piece there have a little piece that hangs off. It's called an oil dipper. And basically what it does as the connecting rod moves, it just kind of dips down into the oil at the bottom of the engine. And it kind of just grabs a little bit and it flings it all around the engine. And that's how the inside of the engine gets lubricated. We don't actually have oil filled all the way up to the top of the engine here, right? We really just have oil kind of in the bottom little section here. And so that little piece on the bottom would just kind of dip and kind of fling the oil around. And that's how we're keeping the engine lubricated, okay? All right, here's a little bit more detailed look at the piston specifically. So the piston has a lot going on in it, okay? It's changed over the years dramatically, and I'm sure it continues to change and become more efficient. But basically, the piston needs to fit inside of the cylinder of the engine with a complete vacuum-tight seal. And in order to do that, we're going to use what we call piston rings, okay? You can see in the bottom right-hand corner a picture of the rings. Here's actually the retaining clips and the piston pin taken out as well. So you're typically going to have 3 piston rings on your piston assembly. The top 2 are going to be what we call compression rings, and these are really there to take on the force of compression that is put out both by the explosion in the power stroke and also keeps the cylinder vacuum or airtight during the compression cycle as well. Okay. Sometimes these rings can be specific to a position, meaning that one ring specifically goes on the top and another one goes in the middle spot. Oftentimes they will have marks on them, or they may actually have a different shape. If you look at the very end of the piston ring, it's hard to see from this picture here, but they may have an ending that it's not square. It might have a bevel or a chamfer to it. And in the manual, you'll find information on how to specifically put those back together. Okay. Third ring is typically the oil ring. This one's easier to identify. It usually has a little kind of wavy metal wafer in the middle. And the job of this ring basically is to allow oil to travel up through the inside of the piston. And then there's some small holes that lead out to the oil ring. And then oil makes its way out to the edges of the piston. And as it moves up and down, the oil ring is constantly putting a nice layer of oil on the cylinder. Okay. So right in here in the engine, right, it's just kind of as the piston's moving up and down, it's oiling the walls so that the piston stays cool, at least the bottom half. Okay. And, if there's a case where an engine is burning oil, it typically would be because one of these rings or more is leaking and oil is making its way up into the top of the cylinder where fuel is being burned. Now the oil is being burned, and that can quickly become a problem because we're going to run low on oil and parts are going to overheat and break. Okay. And you can see there's quite a few other areas of the piston here. Okay, we've got the very top, the head. We've got the lands, which are the proper name for where all the rings fit. And then we also have some oiling holes on the inside. We also have a large area down at the bottom, or a smooth area, that's called the skirt. And this is really just to help keep the piston centered inside of the cylinder and moving correctly. Okay. Overall, the power that an engine can put out is directly related to the diameter of the piston and also how far the piston moves in a given stroke. Okay, so you can measure those two values and we can actually calculate what the horsepower of an engine should be. If you've ever heard of like a bore kit, typically this means that we are making the cylinder larger and putting in a larger piston head so we can actually generate more power out of that same engine.